Hello friends, I am Eknath Kulkarni. Here I am going to deliver you the lecture on IoT for the mechanical students. Today's lecture is mostly related to mechanical because I heard that most of the mechanical students are interested in IoT but they don't know how to carry out the IoT projects. So today's lecture is for the mechanical students only. Okay, I am going to start here. What is IoT? IoT is nothing but Internet of Things. Internet of Things. What mechanical students think that everybody is working on the IoT. Electronics guy comes in front of them and they are telling that I am working on IoT. Computers are working on IoT. Electrical guys are also working on IoT. What does that mean? IoT is interdisciplinary, or it is related to one kind of branch. Actually, from the perspective IoT is interdisciplinary, but from the actual implementation, everything, if we consider the mechanical branch, we will able to put everything related to the machines on the web, like CNC machine. If company wants to do the analysis of CNC machine, they are putting the everything related to CNC machine, means machining and how much machining, wear out part analysis, whole the things on the web. This is called as IoT. One more example we will take directly about washing machine. If company wants to do the analysis of washing machine, the robustness of the washing machine, whatever the jobs given to the washing machine is kept on the web directly by from the users directly. This thing is nothing but IoT, Internet of Things. If computer guys working on the IoT, they are mostly dealing with the analysis and putting the informations on the web, and electronics guys are mostly doing the work on control systems, controller. Electrical guys are also working on them. They are taking the data, fetching the data from the controller, and they are putting the data on the web. But mechanical guys are not that much aware of the Internet of Things. That's why I am taking today's lecture. Okay, today's lecture agenda is introduction, technologies of IoT, Arduino examples, and robotics and mechatronics. Introduction. In introductional part, we are going to see the what is IoT, how it works, and what does that mean. Whether it is useful for everybody or whether it is not that kind of useful thing. We are going to see technologies of IoT. Different kinds of technologies, new kinds of technologies are there, and how we will able to embed new kind of technology in IoT. This is we are going to see. Arduino examples. Mostly the IoT work is related to the embedded systems and free embedded software, which is open source and most widely used and easy to use software is nothing but Arduino. It is the market price of Arduino is 300 from the Indian currency, and it is easily available, and the design is also easily available. You will able to prepare the Arduino. Just add Mega 328 and 256160. These are the series through which these are we are going to prepare the Arduino, but mostly it is the good practice when you directly purchase the Arduino, okay, from the market. Then we are going to see the robotics and mechatronics, how these two branches are related and how these two branches contribute to the Arduino, because today's lecture is mostly related to the only mechanical guides. Okay, just first in introductional part. Introduction. If you think that the internet had changed your life, think again. The IoT is about to change it all over again. Means nowadays everything is on the web, Facebook, WhatsApp, and different kinds of social medias are there. We are sharing a huge data, and we are giving the information, we are taking the information. So if somebody wants to know about you or know about anything, he will directly go to the internet. That's the thing of internet. Okay, And in Indian Prime Minister Narendra Modi has come up with zero defect and zero effect policy. What does that mean? It is actually a boosting policy for the IoT, and most of the companies are working on it. Zero defect means if a product is prepared, it must have gone through the lots of robustness testing, and the product is so robust that it hits the market. And second thing is zero effect policy. If mechanical or any product we are going to prepare, there are lots of processings are there, different kinds of processings are there, so that requires different kind of energies, and this generates a harmful noises, harmful polluted elements. So the Narendra Modi has given the hand to zero defect and zero effect policy. Zero defect means 100% robust, and zero effect means natural environment, which most of the companies are preferring for doing the any kind of activity. And this is the new thing and good thing policy which is launched by the Indian government. Then the definition, I think this is a bookish definition which I got from the some book. Internet of Things is the network of physical objects, devices, vehicles, buildings and other items which are embedded with the electronic software, sensors and networks connectivity, which enables these objects to collect and exchange data. That means that in these many physical objects we are going to connect it to the web. We are lightning put the light on the things so that it will come up to the web. This is the Internet of Things. Means whatever data we have, we are sharing on the web, and we are doing the then next slide we are going to see this is the brush. Actually the design is quite we know how the design of the brush is there. And what do you think that about this design, and what is the cost? Actually the nominal cost of the brush is 20 to 23 or 30 rupees at max, but the cost of this brush is 15,000 to 16,000 because of only IoT. In this, the brush is going to analyze the whole internal things of your teeth, like a dentist, and he is going to take care of your teeth. What is your what you have eaten in the last night, what's the smell, how much time you keep your open your mouth, whole things. These are the new technologies which is implemented in this brush. And the cost of the brush is 15,000 and nominal cost of the brush is 30 rupees. So just see the difference. Who has prepared the first brush? This is the mechanical thing, and mechanical students have developed these kinds of thing, but where is the credit? Nobody is going to give the credit over to the mechanical students, because of only they are only focused on mechanical things. They are not focused on electronics and software things. So that's why there is need to study the IoT. This is one kind of example. What these examples indicate? This example is nothing but a small computer, which is mechanical computer, which is prepared by the mechanical students, and this is first computer. But now today's computer is like this, multi Windows operating system. And who has developed this? This is developed by integrated systems, like everybody interdisciplinary, mostly related to the electronics and software students. Software guys have developed these kind of multi-window operating systems. But what mechanical guys are doing now? Just they are chilling and they are enjoying, nothing more than that, just a happy life. But actually they are facing huge problems in the market. Nobody is going to take a mechanical guy because they want everything to be automated. The person must know mechanical things along with the electronics and softwares. So there is need to beat the market. So start from the today itself to beat the market. Yes, we are going to start it. Then what is IoT? Now we are going to actual the code part of the IoT. What is IoT and how to prepare IoT objects? Just think over it. If bottle is there, just normal drinking bottle, water bottle, and if I want to make it as a IoT bottle, what should I do? I first check the water, the temperature of water. I will indicate that water temperature, then pH value, then some advanced level of water indicators. This is the thing, and this is nothing but the IoT. Normal bottle is 10 to 15 rupees, but the IoT bottle is 5,000 to 6,000. Huge kind of difference is there. How these IoT objects are going to prepare? First, we are identifying the task that we have to connect this bottle to the web, and whatever necessary sensors are required to connect or to sense the information of the bottle, we are going to connect it. So first of all, identification, we have identified the task, then we are going to divide it: mechanical design, electronics design, and software design. These are the three mostly everybody is preferring this model. Then signal conditioning. Signal conditioning is nothing but we are taking the data, we are fetching the data from the sensors, and we are sending it to the controller. So this whole thing is called a signal conditioning. And connected to the network, whenever controller means 50% work has been over completed. Now we are going to send that data to the web. If we will able to fetch the data to the controller, we will able to fetch the data to the PC. The controller and PC, there are huge this is the easiest way to communicate to the PC or directly to the web. So if we are able to fetch the data from the controller, and from the controller side we will able to send it to the cloud. Analysis, whatever data we are going to fetch, we are there are two types of analysis: previous analysis and end analysis. Previous analysis is before doing any task. This is actual actuation analysis, and after implementation of task, this is actually a analysis of whatever you have implemented. Okay. Then there are two new concepts: web 2.0, web 3.0. First, what is the meaning of web? WWW, World Wide Web. It is actually a network of topologies. Different kinds of topologies are connected on the web, and we are going to communicate. Just see our example of mobile. Mobile is consist of 20 to 25 sensors, and every sensor, if we will able to send data on the web from the each sensor, huge kind of data, 1:20, and now everybody has 2 to 3 mobiles, means 1:60 is the ratio of the sensors data, and this is a huge data. We are going to interact that data through the web, so we have to send it to through the web. This whole thing is carried out through the web 3.0 or web 2.0. Web 1.0 is nothing but a first one-way of interaction, in which we are going to interact with the world with the one way, means sender is sending the information and receiver is only receiving, means nominal kind of information. Like if anybody wants to purchase go to the website, he will able to go to the website only. There is nothing more than that, just a textual information. But now we are able to see the visual information, we are able to see interact with the customer and dealer directly. Two-way interactions are there, like a Facebook. Here in the Facebook, simultaneously multiple groups are there, multiple parties are there, they are going to communicate, they are going to chat with each other. This whole thing is nothing but web 2.0. But now web 3.0 is related to the IoT. It's mostly based on the analysis and analysis, but most of the companies are working on the pre-analysis also. Hand analysis means most of the camera, our mobile applications are working on it. If I had taken any kind of snapshot, just if I had taken a snapshot of any guy, the snapshot itself will able to tell that who is that guy, what kind of activity he has done, where is he is from, and what are his previous activities. Like that data is fetched up on the Facebook from his account, and it is going to display to you. This is Web 3.0. Now there are two videos, just go through these videos. These are the best videos and these are available to the web, and I had taken this from the YouTube only. Just go through it for the introduction purpose of the IoT, nothing more than that. There is no such any kind of advertisement. I am taken this video for the introductory purpose, and this video is available on the YouTube. That's it.
Do you think an orchid will ever be able to tell its story? Do you think a flower will one day tell us where it was grown? How it was grown? Or how it got here? Do you think it's possible to teach traffic to speak? Do you think a car can call an ambulance faster than a phone? Do you think it's possible for devices to automatically deliver important, often life-saving data to those in charge? Can you imagine an ambulance that gathers critical information before arriving at the hospital? And that a patient could be examined before he even enters the emergency room, saving precious time for the patient and his family. None of this is science fiction. It's all part of a concept that our team has been working on for several years, the Internet of Things.
And this is the architecture.
The main challenge for making this
What
dream
I
come
told
true
in
is finding
previous
a way to connect many different applications and technologies in one coherent network.
The thing is, they are not connected.
For instance, there are 6 different systems at work in our medical example. We call them silo applications. Before the devices can talk to each other, we need to provide them with a common language. In other words, a set of design rules, protocols, and interoperable technologies. That's exactly what IoTA does. It installs a sort of grammar. IoTA's first task is to identify the basic components of each application silo. Next, all those components must be broken down into smaller elements. IoTA now arranges those elements into a more general framework, the IoT Architecture Reference Model ARMS. The IoT ARM is a sort of compendium for a common language of the Internet of Things, a toolbox for developers. So yes, in the future, things will talk to us and to each other to make our lives easier and safer. And we will make them talk.
Okay, we are just this is a second video. Just go through it. This is also useful.
By now, you may have heard the term Internet of Things. Sounds interesting, but what does the Internet of Things actually mean? IoT is an evolution of mobile, home, and embedded applications that are being connected to the Internet, integrating greater compute capabilities, and using data analytics to extract meaningful information. Billions of devices will be connected to the Internet, and soon, hundreds of billions of devices. As related devices connect with each other, they can become an intelligent system of systems. And when these intelligent devices and systems of systems share data over the cloud and analyze it, They can transform our businesses, our lives, and our world in countless ways. Whether it's improving medical outcomes, creating better products faster with lower development costs, making shopping more enjoyable, or optimizing energy generation and consumption. Here's an example of the big picture. Imagine an intelligent device such as a smart traffic camera. The camera can monitor the road for congestion, accidents, and weather conditions, and communicate that status to a gateway that combines it with data from other cameras, creating an intelligent citywide traffic system. Now, imagine that intelligent traffic system connected to other citywide transportation systems, which get data from their own intelligent devices, creating an ever larger intelligent system of systems. The really big possibilities come from analyzing the end-to-end data across that system of systems. For example, let's say the city's intelligent traffic system detects massive congestion due to an accident. That insight can be sent to the citywide transportation system, which can analyze the accident's impact on other city systems. Recognizing the accident is near the airport and two city schools, it could notify those systems so they can adjust flight and school schedules. It can also analyze and derive optimal routes around the accident and send those instructions to the city's digital signage system to guide drivers around the accident. And that's just one example of the potential benefits that can happen when intelligent devices share insight with other systems, forming ever-expanding systems of systems. But how do we get there? Regardless of the solution,
we are going to see the Arduino. This is the Arduino Uno board. There are different kinds of Arduino boards are there. Uno is there, Mega is there, Nano is there. Different kinds of Arduino boards are there. Here we are going to see the Arduino Uno board. There are 13 digital pins available in the Arduino Uno board, as I am going to show you. Then 3 ground pins are there with reference to the 5-volt supply. 5-volt supply is there, 3.3-volt supply is there, VIN is there, reset button is there, reset pin is there, TX and RX pins are there, and these are whatever you are seeing, that sinusoidal design. This sinusoidal design is nothing but a PWM pulse, and these are used for giving the PWM pulse output. Okay, and this is the crystal, this is the USB jack, 5 to 15 volt power supply is there, hard reset button is there, and this is a small IDE which we are using for the development for the Arduino board. Any kind of programming. There are 2 types of functions are there. First is setup function is there, and second is loop function is there. In setup function we are going to initialize the pins, and in loop functions we are going to initialize, we are actually carrying out the activities. Okay, then in the next slide, Arduino shields are there. Normally if you want to work with your Ethernet cable with Arduino, their shield is available. Directly purchase it and place it on the Arduino. You will able to enjoy the internet also. If you want to prepare signal system projects, or if you want to prepare your sound recorders, video recorders, audio recorders, or audio player, MP3 player, you will use SD card shield, and 7 segment shield is also available to see the output, and for carrying there are many kinds of shields are available. If any technology are there, Arduino is open source, so most of the companies are working on preparing many kinds of shields. You will directly purchase it and use it. If you want to do any kind of signal conditioning, whole signal conditionings are available, and this is the best thing which you will able to use it on your, with the help of your kit. Okay, this is the breadboard design. For the mechanical students, I know electronics and computer guys well aware of some of these breadboards. The breadboards, if I connect the power supply to this point, it will directly gives the whole link is connected. So I will able to get the output from here also, from here also. Same like from the blue wires, and these are the horizontally connected for the just introductory purpose I am going to show you. Then next is I am going to give or take the demonstration on the POT potentiometer. In potentiometer is nothing but it's variable voltages are available through the pot. This is 10k pot is there with us, and one side you have to connect the power supply, other side you have to connect the ground, and from the middle where you will get the referential voltage from 0 to 5. This is the pot which we are using for the fitting the LED or different kinds of small projects are there. Then second is this LDR is there, LDR sensor. Light dependent resistance is there, in which when light is bombarded on the LDR, it will changes its own resistance. So for taking the readings from the LDR, we require a referential resistors. We are taking referential resistor as a 100 ohm, and normal LEDs are there for just introductory purpose, plus or minus. The leg with highest height is nothing but a anode, and leg with lowest height is nothing but the cathode. Okay, then we are going to show the see the experiments on the LM35 buzzer. LM35 consists of VCC, via output voltage and ground voltage. Buzzer is also same as your LED. And third is these pins are GR, is mostly related to your servo motor. These consist of power supply. Black is your ground, and orange is nothing but the pulse. Then these are demos which we are going to take: LED display, buzzer, DC motor, stepper motor, LM35, and whole data. Afterwards we are going to see the why we need a cloud, because huge kind of data is there, continuous monitoring there. It is not possible through the normal type of computer, normal type of PC. We have to use the cloud. Tracking and learning minimization. As my previous lecture I told that the tracking and learning minimization requires used in most of the companies. What they are doing, they are tracking your activities. They are teaching these activities to the robots, and robot is carrying out the next activity with the help of teach pendant or anything. This is tracking and learning minimization. Daily the sensors are tracking you, and on that basis they are going to teach the things to the robots, and robots are carrying out the same thing. This is called as tracking and learning minimization, and this is harmful for the most of the workers, because robots are taking place of our persons. But actually this is if we see this from the industrial perspective, this is a good thing. Anybody will able to run his own industry by using this kind of mechanism. Data analysis is when I will able to send the data to the cloud. Data analysis, I will able to do any kind of analysis, and if I make this available to whole many people's open source, anybody will able to create the libraries, anybody will able to share the data, anybody will able to do analysis. This is data analysis is when I will use the cloud, because direct huge kind of storage is available with me. Monitoring sophistication, I will able to monitor it, what kind of activity is going on. If some remote plant, if I want to run the plant from the remote location, I will able to run it, but how to monitor it? This I will able to monitor it with the help of cloud. 24 hours of production. As we have seen that we are using the robotics for doing this kind of activities, so mechanical will going to bit whole the world. So this thing is carried out with the help of the cloud only. So we need to study the embedded systems, then we need to study the robotics, and we need to study the tracking and learning minimization. Okay, and next part is here comes the big one, industrial standard 4.0. Most of the industries are working on the industrial standard 4.0. What does that mean, industrial standard 4.0? Actually, industrial standard 4.0 is nothing but a digital world. In this, we are going to create the everything digitally. Everything paperless and digital activities are we are focusing on the digital activities. This is nothing but industrial standard 4.0. We are when we are using this digital world, we mostly deal with the robotics, and robotics are nothing but we have to maintain for the accuracy and precision for the robot, and it is not the simplest task. This is the best challenge for the control system students. Each info is analyzed. This is also a best thing. Whatever things which we are going to carry out in our form, we are going to analyze it before carrying out and after carrying out. These two kinds of analysis and middleware carrying analysis will be there for the how the object or your production is going to enhance the activity. This whole thing is carried out with the help of analysis, and this the cloud is helpful for doing this kind of activity. Fast production, when we are using the robotics, automatically the fast production will be there. Transparency, just see if I want to buy transparency means user will able to know the what kind of activity has been carried out in his product, or what he is taking. If I taking the four-wheeler from the Ford or any kind of industry, I want to know that which parts are there and what's the costing, and how much robust parts are there. So this is the transparency. Each client wants a transparency. So this kind of transparency is maintained with the help of Industrial Standard 4.2. Just see the video. This is one kind of video which is available on the YouTube also. This is Volkswagen video, and why we are using Industrial Standard 4.0. They are taking them.
Technologies are changing the world. They're also making the cars manufactured by the Volkswagen Group more efficient, safer, and more customer-friendly. The nature of car manufacturing is also changing in a similar way. In fact, the next batch of innovations
These videos are available on the net, and I taken these videos from the net for the just introductory purpose, nothing more than that. And here we are going to stop. Actually, if you want to see more videos related to Arduino, let me know. I will share the videos of Arduino and my programs also. And if you want to know about any different controllers, let me know from the comments. I will share the all the videos and all the data related to you. And okay, thank you for listening, my friends. Thank you.